Hello friends, welcome to the Engineering Projects YouTube channel. I am Mariam. We have started the series of Electronic Devices and Circuit Theory by Robert L. Ballisted. This is our chapter number 2 and its name is Semiconductor Diode Applications. In our previous lecture, we have discussed about the full wave voltage doubler circuit and the half wave voltage doubler circuit. In this lecture, we will discuss about the voltage tripler circuit, voltage quadruple circuit, and I will explain the output difference of clipper circuit, clamper circuit, rectifier circuit, and the multiplier circuits. We have discussed about these terms and what is the difference between the output of these terms. I will at the end of this lecture I will discuss this. So what is voltage multiplier circuit? We have discussed about this definition in our previous lecture. So a voltage multiplier is a specialized rectified circuit producing an output which is theoretically an integer times the AC peak input. So it is theoretically the integer times the AC peak input. When we have voltage is equal to 2 Vm, then we will call it as the voltage doubler circuit. When we have the voltage, output voltage will be equal to 3 Vm, then we will call it as the voltage tripler circuit. And when we have the output voltage is equal to 4 Vm, we will call it as the voltage quadruple circuit. For the voltage tripler circuit, I have drawn the circuit here. This is our transformer to supply the AC input. This is our capacitor C1, capacitor C2 and capacitor C3. This is our diode D1, diode D2 and diode D3. And how these diodes are connected, it is important. These two diodes are connected as its P type is connected at the upper terminal and N type is connected at the lower terminal. But the diode D2 is connected in such a way that its N type is connected to the upper terminal and the P type is connected to the lower terminal. For the positive half cycle, for V input, for positive half cycle, there will be positive, there will be negative. There will be positive, there will be negative. Our diode D1 will be forward biased and our diode D2 will be reverse biased, diode D3 again will be forward biased. So diode D1 will be forward biased. So our current will start to flow in this direction, positive to negative, and our peak voltage is Vm. So our capacitor C1 will be charged to the level Vm. As the current flows, so our capacitor will charge to the level Vm. It will have the positive here and negative here, positive with connected to the positive. So now for the positive half cycle, for this half cycle, our capacitor C1 is charged to the level Vm. Now for the negative half cycle, for negative half cycle, there will be negative and there will be positive. For negative half cycle, our diode D1 will be reverse biased, so it will act as the open circuit. Our diode D2 will be forward biased because its N type is connected to the negative terminal, so it will act as the short circuit. Now our current will flow in this direction from positive to negative, in this direction. Now applying the Kvl equation to find the voltage level of C2. Apply the Kvl equation. So we have started from here, minus Vm, which is the input maximum voltage, and here the polarity will be plus, it is connected to plus, and there will be minus, and minus Vm plus C2 and minus Vm is equal to 0. So our C2 will be charged to the 2 Vm level. So C2 is charged to 2 Vm level. Now again for the negative half cycle, for the positive half cycle, when again positive half cycle came, our this capacitor is being discharged. This capacitor is being discharged and this capacitor charged this capacitor to the level Vm, 2 Vm. For again for positive half cycle, there will be positive, there will be negative. The polarity of the capacitors will not change. Now this positive input signal, this input half cycle, try the diode is like this and this diode is like this. Now this input signal trying to make this diode forward biased and this diode reverse biased. So this will be open circuit and these two diode will be in the forward biased condition for the input signal. This input signal trying to make this diode and this diode, diode D1 and diode D3 in the forward biased condition. But this capacitor with the potential of 2 Vm trying to make this diode reverse biased because its N type is connected to the positive terminal of capacitor. This input signal with the potential of Vm trying to make this diode forward biased, but this capacitor with the potential of 2 Vm trying to make this diode reverse biased. As the potential of capacitor is higher, so capacitor will win and our diode will be act as reverse biased. As the capacitor is winning, so this capacitor will make this diode reverse biased and it will act as again open circuit. Now our diode D3, its negative terminal is connected to N type, so it will be act as forward biasing condition. So it will be the closed circuit here, short circuit here. Now our current will flow in this direction. Now applying KVL to find the polarity of C3. Applying the KVL to find the polarity of C3. Starting from here, minus Vm, which is the input maximum voltage, plus Vm now the capacitors will be positive and negative, plus C3 and now minus 2 Vm is equal to 0. This plus Vm will be cancelled out this minus Vm and so C3 will be charged to the 2 Vm level. So our C3 will be charged to the 2 Vm level. Now we don't want to take our output across this. We want to take our output across these two capacitors. So we want to take our output across these two capacitors. So our output, final output will be the V0 will be equal to Vm plus 2 Vm. V0 will be equal to 3 Vm. So this we will get the voltage tripler circuit like this, and our voltage tripler circuit output waveform will be like this. And in the DC form we will get the value like and this is the 3 Vm maximum voltage level. Okay. Now we will discuss about the voltage quadruple circuit. For voltage quadruple circuit, we have connected the 4 diodes and 4 capacitors. This is our diode D1, diode D2, diode D3 and diode D4. This is our capacitor C1, C2, C3 and C4. For positive half cycle, there will be positive, there will be negative. Our capacitor polarity will be positive and negative. Our diode D1 will be forward biased, so it will act as the short circuit. Our current will flow in this direction and our capacitor C1 will be charged to the level Vm. Now for the negative half cycle. For negative half cycle, there will be minus, there will be plus, and our capacitor C1, our diode D1 will act as open circuit and our diode D2 will act as short circuit. So now our current will flow in this direction. Applying KVL to find the voltage at C2. So our current will flow in this direction. Minus Vm, there will be plus, there will be minus, plus C2 and minus Vm. So our C2 will be charged till the level 2 Vm. So now our capacitor C2 is charged till the level 2 Vm. Now again for the positive half cycle, there will be positive, there will be negative. The polarity of capacitors will not change. For again positive half cycle, our diode is in this condition and this diode is in this condition. For positive half cycle, this is trying to make this diode forward biased, input signal trying to make this diode forward biased, but our capacitor C2 is trying to make this diode reverse biased. As the polarity of as the voltage of capacitor is higher, so it will be reverse biased and act as the open circuit, and our input signal is trying to make our diode D2 as the reverse biased, so it will be reverse biased, and our capacitor C2 is also trying to make it reverse biased, so it will remain reverse biased. Now our diode D3 will be forward biased and our current will flow in this direction. Now again applying the KVL equation, so we will have minus Vm plus Vm, there will be plus, there will be minus, as C3 is connected to plus terminal, so there will be plus C3 minus 2 Vm is equal to 0. Plus Vm will be cancel out this minus Vm and C3 will be at 2 Vm. So now our capacitor C3 is charged till the level 2 Vm. Now again for negative half cycle, when there again negative half cycle came, then our 3 diodes D1, D2 and D3 will remain open circuit. These 3 diodes will remain as open circuit, and now our current will flow in this direction. Now again applying the KVL equation, we will have minus Vm plus 2 Vm, its capacity, there will be plus, there will be minus, plus C4 minus 2 Vm minus Vm is equal to 0. There will be minus Vm plus 2Vm plus C4 minus 2Vm minus Vm. This minus 2Vm will be cancelled out by this plus 2Vm, and C4 will be equal to 2Vm. So our capacitor C4 is charged to the level 2Vm. Now the question is where we want to take our output. If we want to take our output at this point, then we will have the circuit like voltage tripler circuit. But if we want to take our output at this point, then our circuit will be voltage quadruple circuit, because V0 will be equal to 2Vm plus 2Vm is equal to 4Vm. Similarly, we can get the circuit with 5Vm. To get 5Vm, we have to apply here another diode D5 and another capacitor C5, and we have to take our output across this terminal. So now at the end of this lecture, I have discussed that I will discuss a short difference between the output circuits of clippers, clampers, rectifiers and voltage multiplier circuit. So for the clippers, we have the input like this. Clippers will clip away the portion. So the clipper will clip away the portion. So it has clipped away the negative portion. So it is called the negative clipper. Now for clamper, we have the input signal like this, or we have the input signal like, in my lectures we have used the input signal like this. It is easy to deal for clamping signal with the square shape input signal. So our output signal will be like this, and it is called the negative clamper signal. As this is clamped in the negative direction, so it will be called the negative clamper. So what kind of rectifier filter is? Rectifier circuit is, for rectifier we have the input like this and our output will be like this. For full wave rectifier, we will have the output like this. We will convert the AC into DC. So this blue line shows the DC signal. Now voltage multiplier signal, what to do with voltage multiplier signal? So this is our input signal, and voltage multiplier will multiply the input signal with an integer number. So this is the output waveform of voltage quadruple signal. Okay, so this is the difference between the clippers, clampers, rectifiers and multiplier circuit. So now our chapter number 2 is completed. In our next lecture, we will discuss about the BJTs. So if you like our lecture, then kindly subscribe our channel. Thank you.